Therefore, the final answer for this is obtained as 2 by root 5 sine inverse 2x minus 1 by root 5 plus c is what we obtain for the given question. Therefore, integral of 1 by root 1 plus x minus x squared dx is 2 by root 5 sine inverse 2x minus 1 by root 5 plus c using the complete square method. Now let's take a quick session on evaluation of integral this, because this is as similar as the previous two sessions we have taken on the complete square method. So when I have an integral of this where you don't have the denominator but the numerator, say for example I compare this with the example problem, I evaluate integral of root of x squared plus 2x plus 5. Now I compare this with this, and clearly I can make this a perfect square by taking common, and then this reduces to the form of this, and clearly this can be reduced into this form, and we know that integral root x squared plus a squared dx is half x root x squared plus a squared by 2 sine h inverse x by a plus c is what we substitute here, where a is 2 and x is x plus 1. So is how we do it, and then finally the simplification gives us the required answer. So this is as similar as the previous sessions. The ultimate destination is to make this a perfect square. Integration of root ax squared plus bx plus c dx is done using the complete square, and then using the formula this equals this. Now next is the evaluation of the integrals of the integral in the form px plus q by root of ax squared plus bx plus c dx. Now how do we evaluate which has the functions both in the numerator and the denominator is what we are going to see in the session. So in order to evaluate integral px plus q by root ax squared plus bx plus c, then the method is not by complete square, but we have a different method which we are going to see now. So let's take an example problem and try to understand solving integral of this type. So let's take an example problem and then understand the similar method of evaluating the general form of px plus q by root of ax squared plus bx plus c. So to start with an example problem out here, if I wanted to evaluate integral of x plus 1 by root of x squared plus 3x plus 12 of dx, then this is clearly in the form px plus q by root of ax squared plus bx plus c. And of course, where a, b, c and pq are real numbers. So in order to evaluate this integral, we have taken x plus 1 equals a into d by dx of x squared plus 3x plus 12, the one which is inside the root, that is ax squared plus bx plus c plus b. Now this is assumed as the formula. We have to take this as the formula and equation 1. So utilizing this, we have to solve the integrals of this type. So numerator is a into d by dx of the value inside the root of the denominator plus b is how we understand this step taken as a remembrance formula. So as I proceed with this, I clearly see that d by dx of x squared is 2x, d by dx of 3x is 3, and d by dx of a constant is 0 plus b. That implies 2ax plus 3a plus b is equal to x plus 1 is equal to this. And using this, the coefficient of x here is 2a and coefficient of x here is 1. So equating the like coefficients, we get the values of a and b. Ultimately, the destination out here is to find a and b. Therefore, I equate the like coefficients, and therefore 2a will be equal to 1 and 3a plus b equals 1. And then this reduces to a equals 1 by 2, and therefore substituting in the other equation, 3 times of a, which is 1 by 2, plus b is equal to 1, and therefore b is 1 minus 3 by 2, which is minus 1 by 2. Therefore a is 1 by 2 and b is minus 1 by 2. Now substituting these two values in equation 1, I get this to be replaced with a and b, and then we simplify. So let's see how we can simplify by substituting this in equation 1. Therefore, substitution in 1 gives us x plus 1 equals a, which is 1 by 2 times d by dx of x square plus 3x plus 12 plus b, which is minus half, is what we get out here. Now, as I see the left hand side, if I want to bring this into the question, I need root of 3x square plus 3x plus 12. Therefore, now here dividing by the term root of x square plus 3x plus 12 and integrating over dx, let's see what happens. So initially I divide with this and then integrate over dx. I get this to be x plus 1 by root of x square plus 3x plus 12, but integrated over dx, I get this. And the reason for dividing this and integrating over dx is that when I divide and integrate, I get back the original question. This is the integration I need to find, which indirectly gives me half integral d by dx of x squared plus 3x plus 12 by root of minus half integral 1 by root x squared plus 3x plus 12 of dx. Now this has to be further simplified and then substituted here. Now as I see here clearly, this is in the form f dash x by root fx, where we have integral f dash x by root fx is 2 root fx plus c. So using this formula, this reduces to f dash x by root fx, where f of x is x squared plus 3x plus 12, reduces to 2 root f of x, which is x squared plus 3x plus 12. Then I have 2 cancelled, and finally I get this integral, which has to be simplified using the complete square form as we have taken in the previous session. So let's simplify this to get the complete answer for integral of x plus 1 by root of x squared plus 3x plus 12 dx. Now as we got simplified answer as integral of this is root of x squared plus 3x plus 12 minus 1 by 2 integral 1 by x square of dx. Now I just simplified this and substitute. So let's see how we can calculate the considered part. Using the complete square method. Now this is in the form a square plus 2ab. Now this is in the form a square plus 2ab plus b square and minus b square plus 2l is what we get when I complete through the complete square form. And this, on further simplification, gives us a square plus 2ab plus b square, which is a plus b whole square minus 9 by 4 plus 12, which on LCM gives us integral dx by x plus 3 by 2 whole square, 12 fours 48 minus 9, (39 by 4). 12 fours 48 and 48 minus 9 is 39, which is nothing but integral dx x plus 3 by 2 whole square minus root 39 by 2 whole square. So this is in the form 1 by x square minus a square, which is nothing but integral (1 by 2a) log mod x minus a by x plus a plus c. So this reduces to 1 by 2a log mod x minus a by x plus a. So this would be further simplified by taking 2 cancelled, and this will be 1 by root 39 log mod 2x plus 3 minus root 39 plus root 39, which is substituted in this, and then we get the final answer, which is nothing but root of x square plus 3x plus 2l minus half times root 39 of log mod 2x plus 3 minus root 39 by 2x plus 3 plus root 39 plus c. So integration of px plus q by root ax square plus bx plus c is done using a into d by dx of denominator plus b times plus b, which gives us the complete answer. The method as applied here applies for any problem which has the function in this type. Next is evaluation of the integral of the form plus this dx. If I have a problem which is evaluated in this form, let's see how we can evaluate an integral of this type. So in this case, let's take an example problem of integral 2x plus 3 by x square minus 5x plus 6 dx. Now clearly this is in the form of px plus q by x squared plus bx plus c. So this can be integrated using the process numerator is equal to a into d by dx of denominator plus b is the formula which I apply for evaluating any integral of this type, where nr stands for numerator, dr stands for denominator. So numerator is always taken as a times d by dx of denominator plus b, which on simplification gives numerator, which is 2x plus 3, and a times of d by dx of denominator plus b, which is equation 1. This on further simplification gives a times d by dx of x square as 2x and d by dx of 5x is 5 plus 0 plus b, which on further simplification gives 2ax plus b minus 5a, or minus 5a plus b, which we get in this form. That implies 2x plus 3 is equal to this, which when equating the like coefficients, I get coefficient of x here is equal to coefficient of x here, and the constant is equal to constant. I get 2a equals 2 and minus 5a plus b is equal to 3 is what we get. That implies here my a is equal to 1 and minus 5a plus b is 3, which is substituted in place of a out here. So this becomes b equals 3 plus 5, which is 8. Therefore a equal to 1 and b is equal to 8. So when I substitute this in 1, I get this in the form of this d by dx and the constant. So therefore my value of a is 1 and b is equal to 8, which is substituted in equation 1, then we get 2x plus 3 is equal to a times d by dx of this plus b is what we get when we simplify. Now I divide by this on both sides and integrate over dx. So dividing by this and integrating over dx, I get integral of 2x plus 3 by this, which leads to integral of d by dx of x squared minus 5x by plus 6 whole by this dx plus 8 times integral 1 by this dx is what we get. Now as I compare here, I see that integral of f dash x by fx dx is log mod f of x plus c. So using log mod fx, this reduces to f dash x by fx, which is log mod x squared minus 5x plus 6 plus 8 integral 1 by this dx. Now it is now the task of integrating this using the complete square form and then substituting in the whole of the integral, and then we get the complete answer. So this can be done using the previous case of complete square method and then substituting that integration as we have done in the previous case, we get the answer, which is integral of the required question. Next, we have integration of the type evaluation of integral px plus q times root of ax square plus bx plus c dx. So when I want to evaluate integral of this type, let's see how I can do that. So evaluation of integral of this type, say for example, I take the example problem 3x minus 2 times root of 2x squared minus x minus 1 dx. Then let's see how we can integrate this. So in case of this, I take 3x minus 2, that is px plus q, equals a times d by dx of 2x squared minus x minus 1 plus b is what we get on this simplification. So we assume this to be a formula which we remember for integration of the type px plus q times root ax squared plus bx plus c. So this equals a times d by dx of something inside the root plus b. Next, simplifying this further, I get a times d by dx of 2x squared is 4x minus 1 minus 0 plus b, which gives me 4ax plus minus a plus b is what we get. Now, equating the like coefficients, I get 4a equals 3 and minus a plus b equals minus 2. That implies my a is equal to 3 by 4 and my b minus of 3 by 4 plus b equals minus 2. That implies b as 3 by 4 minus 2, which on LCM gives 3 minus 8 by 4, which is minus 4. Therefore, a equals 3 by 4 and b equals minus 5 by 4, which I am going to substitute here and simplify. Therefore, substituting in 1, we get 3x minus 2 is a times d by dx of 2x squared minus x plus 1 plus b, which is minus 4, is what we get when you substitute in terms of a and b into the equation. Now, multiplying both sides with root of 2x squared minus x plus 1 and integrating over dx, we get this to be integral of 3x minus 2 root of 2x square minus x plus 1 dx is equal to 3 by 4 integral d by dx of 2x square this times root of this dx minus 5 by 4 integral root of 2x square minus x plus 1 dx, which is multiplied to each of the terms of equation 1, is what we get. Now we have a formula which can be simplified for this integral, which is done using the formula integral f dash x into f power nx dx is plus c, or this is f of x whole power n plus 1 by n plus 1 plus c. So using this formula, I can reduce this into the form taken here, 3 by 4 integral d by dx under root taken as 1 by 2 dx minus this, which comes same. This is in the form f dash x into fx whole power n, that is, this is simplified using the formula fx whole power n plus 1 by n plus 1. So your f of x is this, therefore 2x squared minus x plus this by n plus 1 by n plus 1 minus 5 by 4 integral of root 2x squared minus x plus 1 dx is what we get. So this is n plus 1 by n plus 1, which comes like this. And this is simplified using the complete squared method, where I reduce to the form integral root x squared plus a squared, or integral root x squared minus a squared, where I simplify using this respective formulae after converting this into the complete squared form. And this is directly with the formula which we have in this form. So simplifying this by using complete square sum and writing them together is the final answer for the question which demands for integral of this root of this dx in the form px plus q root ax squared plus bx plus c. Integration connected with complete square form. Now let's evaluate integral a cos x plus b sin x plus c by d cos x plus e sin x plus f, where the condition is that each of a, b, c, d, e and f are real numbers and d and e are non-zero, because if d and e are 0, then the whole of denominator vanishes and the simplification becomes easier. So with this condition, let's see how we can evaluate an integral of this type in the session. So usually an integral of this form, integral of this, is evaluated using the property numerator, which I denote with nr, is equal to a times d by dx of denominator, or derivative of denominator, plus b times of denominator plus c, is how we assume the formula in case of evaluating the integral this. So numerator is assumed with a times d by dx of denominator plus b times of denominator plus c, and then we just reduce the left hand side into the integral form as given in the problem, and then we get the solution. But ultimately this is the formula for evaluating the integral of the type a cos x plus b sin x plus c by d cos x plus e sin x plus f. Now let's take an example problem to support the evaluation of integral of this type. So let's take an example problem similar to the type as given in the session. So for example, I take an example problem of evaluating integral cos x plus 3 sin x plus 7 whole divided by cos x plus sin x plus 1 dx. Now evaluation of integral cos x plus 3 sin x plus 7 whole divided by cos x plus sin x plus 1 dx is very much represented with this, where a is 1, b is 3, c is 7, d is 1, e is 1, f is 1. So let's see how we can evaluate using the method for the integration of this. So we know that numerator is a times derivative of the denominator plus b times of denominator plus c. Let's try to utilize the numerator, which is cos x plus 3 sin x plus 7, and the denominator, which is cos x plus sin x plus 1, substituted in this formula. Now my numerator comes in the left hand side as supported with the formula. Therefore cos x plus 3 sin x plus 7, which is equal to a times derivative of the denominator, that is the constant a, times of denominator derivative, that is d by dx of the denominator, which is cos x plus sin x plus 1, which comes there. And next is b times of denominator, which comes in the second stage of, and hence I write this as b times of denominator, which is cos x plus sin x plus 1, and then followed with c. So we get this a times this, b times this plus c, which I am going to evaluate. So evaluation of this leads to cos x plus 3 sin x plus 7 is equal to a times of d by dx of cos x is minus sin x, which is using the standard formula of derivatives, and d by dx of sin x is cos x, and derivative of a constant is 0 because d by dx of 1 is 0. And similarly, this would be b times cos x plus sin x plus 1 plus c. Now I try to take all cos x terms one side, sin x terms one side, and all the constants to the other side. So I pair the cos x terms, sin x terms, and constants as in order. So therefore, let me first start with cos x terms. Now I have a cos x term here and here, which comes as a plus b cos x when I expand the bracket and take cos x common. Similarly, when I have sin x, I can take this as minus a plus b of sin x, as can be clearly seen here. And then taking the constants here, a times of 0 is 0, b times of b is b, so I get this to be b plus c in this case. Now let me take this as equation 1, where my intention is to find the values of a, b, c and then substitute in my equation 1. So being the target that I had to find a, b, c, I am going to use this equal to this in order to find a, b, c. So let's see how we can find the unknown constants a, b, c and then substitute it in equation 1. Now continue from here. Let's find a, b and c. So as I see my left hand side, which is cos x plus 3 sin x plus 7, which is nothing but equal to a plus b cos x, and then plus minus a plus b sine x and then the constant which is b plus c, then I clearly see that there are some like terms in the left hand side and the right hand side when they are combined together. Now, as we see the left hand side and the right hand side, I compare the like coefficients. I see that coefficient of cos x on the right hand side is a plus b, which is equal to the coefficient of cos x on the left hand side, which is 1, by comparing or equating the like coefficients. And similarly, I find that coefficient of sine x, which is minus a plus b on the right hand side, is equal to the coefficient of sine x on the left hand side, exactly the same. Similarly, the constant on the right hand side must be equal to the constant value on the left hand side. Therefore, this being equal to this. Now, I have three equations and three unknowns a, b and c, which we are going to solve using the elimination method. So, as I see here, first I take these two. Then I clearly see that by elimination method, this gets cancelled when I add them, and then I get b plus b, which is 2b, 1 plus 3, 4. That implies b is equal to 2. Now, when I get the value of b, it is very easy to get the value of a, either substituted in this or this. So, let me substitute this value in this equation. That implies a plus 2 equals 1, and that implies a equals 1 minus 2. Therefore, a is minus 1. B is 2. Now, once I got the values of a and b, it is easy to find the value of c substituted in this, where I substitute this into this equation. Therefore, I get 2 plus c equals 7, and that implies c is 7 minus 2, which is 5, which is this. Therefore, I got the three unknowns which I wanted to find, one being a equals minus 1, b equals 2, and c equals 5. Now, I am going to substitute these three constants in the equation 1, and let's see how further can we evaluate from the values a, b and c. Therefore, a is minus 1, b is 2, and c is 5 is what we got using the elimination method. Now, substituting the above values in equation 1, which we have obtained in the previous case, let's see what exactly we get in the new equation. So, numerator being cos x plus 3 sin x plus 7 is a times derivative of the denominator plus b times of the denominator, that is 2 times and plus c, which I got as 5, is what we get when we substitute the values of a, b and c in equation 1. Now, we have to evaluate the integral. Therefore, I have to reduce the left hand side into the form of an integration, and therefore, in order to get the integral of the required problem, I am going to divide this with the denominator and integrate over dx. Let's see how. Divide both sides with cos x plus sin x plus 1 and integrate over dx, that is with respect to x. So, let's see what happens. So, initially I divide each of the sides with this cos x plus sin x plus 1 and then I integrate over dx, then clearly I understand that my left hand side reduces to the required problem. Is the how we use the technique in finding the integral of this utilizing the right hand side strictly. So the right hand side reduces to minus 1 times integral d by dx of cos x plus sin x plus 1 by cos x plus sin x plus 1 dx, and then the second term reduces to 2 terms of integral cos x plus sin x plus 1 cos x plus sin x plus 1 dx, and finally the last term reduces to 5 times integral 1 by cos x plus sin x plus 1 dx is what we get. Now let's see how each of this is simplified. As we all know that we have a formula which states for the first one integral of f dash x by fx is the formula which you're going to apply in case of evaluation of this, which is in the form integral f dash x by fx, which is log mod fx. And this, both of them being same, can be cancelled, and this reduces to 2 times of integral dx with numerator and denominator being same, cancel, and this dx left over. And finally the last term reduces to 1 by cos x plus sin x plus 1 of dx is how we simplify this. Now next is minus of log mod cos x plus sin x plus 1, and 2 times of integral dx is 2x plus 5 times integral 1 by cos x plus sin x plus 1 dx is what finally we get. Now the biggest question is, how do we integrate 1 by cos x plus sin x plus 1 is the biggest question out here. So let's see how we can evaluate integral of 1 by cos x plus sin x plus 1. Now let's see how we can evaluate integral of 1 by cos x plus sin x plus 1 using exclusively with the trigonometric formulae. So in order to evaluate integral 1 by cos x plus sin x plus 1 dx, I rearrange the terms in the manner 1 plus cos x plus sin x dx. I pair cos x and 1 together and sin x here because I have the formulae which say that 1 plus cos 2a is 2 cos square a, and I have sin 2a is 2 sin a cos a. Now as I see here, I want to compare this with these two formulae because as I can see, I don't have 2x but I have only x. That means, which says that if I have 2a on the left hand side, the right hand side has half of that angle. Therefore my 1 plus cos x, as similar to left hand side, will have the formula in the form 2 cos square of half of this angle, which is x by 2. Therefore 1 plus cos x can be written as 2 cos square x by 2, as 2a is twice of a, or a is half of this angle. And similarly, my sin 2a is 2 sin a cos a. The double angle reduces to the single angle a and a. Similarly, if I assume the formula for sin x will be 2 sin x by 2 cos x by 2. So therefore, I substitute 1 plus cos x as 2 cos square x by 2, and I substitute for sin x as 2 sin x by 2 cos x by 2 using the two standard formulae in trigonometric topic. Therefore, this reduces to 1 plus cos x as 2 cos square x by 2 plus sin x as 2 sin x by 2 cos x by 2 dx. Now this, I can easily take 2 cos x by 2 common, and therefore this reduces to cos x by 2 dx. And then this can be further simplified as 1 by cos is secant x by 2, and cos plus sin, I take cos common, therefore this reduces to sin x by 2 by cos x by 2. So taking cos common, I get in this form, where this cos, when I take it to the numerator, becomes secant, and this on the whole becomes secant square x by 2, because one cos gets as secant into secant, which is secant square this, by 1 plus sin by cos, which is tan, and therefore tan theta is sin theta by cos theta is what we get. But this again doesn't help in finding the integral directly, because I don't have any standard formula which is connected with this integral, and therefore I think of substitution method. So clearly the substitution helps here, because if I take tan x by 2 is some t, then in this case, or I take this as some u, then derivative of tan x, we know d by dx of tan x is secant square x by 2, and by chain rule d by dx of x by 2 is 1 by 2, which is dx equals du. Therefore, this 1 by 2 brought here, secant square x dx will be 2 times of du, that is 1 by 2. If I bring the 1 by 2 here, then whole of 1 by 2 times secant square x by 2 dx is du, which I am going to substitute on the right. Half secant square x by 2 dx is equal to du, and tan x by 2 is u, which comes as 1 plus, or I take 1 plus tan x by 2 is u, so this directly reduces to u. My substitution of 1 plus tan x by 2 equal to u reduces d by dx of 1 as 0, d by dx of tan x as this, so that is not going to affect with 1 plus tan x by 2 taken as u. So this reduces to du by u. We know that integral dx by x is log x plus c, and hence this is log mod u plus c. Substitution of u will give me integral of this as log mod 1 plus tan x by 2 plus c, is how we integrate 1 by cos x plus sin x plus 1 dx using the method of trigonometric formulae. Therefore, we got the integral of 1 by cos x plus sin x plus 1 as log mod 1 plus tan x by 2 plus c, where each of the integral is obtained. Therefore, the integral of the required problem, that is cos x plus 3 sin x plus 7 by cos x plus sin x plus 1 dx is nothing but minus log mod cos x plus sin x plus 1 and then plus 2x and plus 5 times log mod 1 plus tan x by 2 plus c is how we obtain the integral of cos x plus 3 sin x plus 7 by cos x plus sin x plus 1. So evaluation of integrals of the type this in the session are obtained using the respective formulae. Now sometimes the formulae is obtained indirectly, where I have to reduce the given problem into this form and then use the method accordingly. So for example, I have to evaluate integral of this dx, 4 by 1 plus 3 tan x dx, then I don't see this problem clearly in the form as given in the session, but I can convert this into this form and then use the respective methods of solving integral of this as seen in the previous session. So let's see how I can convert this into this form. Integral of 4 by 1 plus 3 tan x, as I know, is sin x by cos x. I use the formula of sin x by cos x for tan x. Therefore, this being replaced with sin x by cos x dx is how we obtain. Now this, on further simplification, gives us the LCM, which is cos x plus 3 sin x by cos x dx is how the LCM is obtained, and this comes to the numerator in the next stage, so that this reduces to 4 cos x by cos x plus 3 sin x dx, which is strictly in the form of a cos x plus b sin x plus c by d cos x plus e sin x plus f, where a is 4, b is 0, c is 0, d is 1, e is 3 and f is 0, is how we understand reducing the given problem into the form integral of this using tan theta. Now let's connect integration with partial fractions in this session. So now that we have discussed about partial fractions in our previous sessions, integration always is connected with partial fractions because some of the integrations which involves the functions need partial fractions in order to reduce that into the standard form. So reducing through partial fractions is very essential in integrating some of the functions. So let's see how we can use the partial fraction method for integration. Now there is no method but directly using an example problem through which we understand the partial fraction method for integrating. So let's take an example problem and understand the integration using the partial fractions. So for example, I would like to integrate x square minus 2x plus 3 by x square plus x minus 2 dx. Now this is not in the standard form, so definitely we need to search for some methods through which I can integrate this with this.